Now, I'm at Bristol Bespoked today, and this is basically the UK's handmade bike show, and I'm joined by someone who I am in complete and utter awe of, because he gets to make the things that we use on our bikes. How cool is that? Mr. Chris King of Chris King Precision Components. Now, we asked you recently, actually, to send in your questions for Chris, and the good news is he's going to answer some of them. So, firstly, welcome.
Thank you.
And well, let's crack on really with the questions, because I know you are a very busy man.
Well.
So let's get started. First question from Nate Weldgood. How did you get started in machining and manufacturing, and then turn into what Chris King is today? Do you have any advice for a new guy who wants to make their own components or bikes?
I used to hang out at a pro bike shop with all the bike racer guys. We used to go on rides and all this kind of stuff. And one time I had taken some rear hub and put some better bearings in it and took it over to show it off, of course. And everybody's like, oh, wow, that's really cool. And this one guy's like, it didn't faze him at all. He just looked and kind of, whatever, right? And I says, what's up? He says, well, that's cool and everything, but if you really wanted to make something cool, you should make a better headset. And I had this idea from having wandered through the warranty department at this medical place. So there was this drum full of all these parts, and there was tons of these bearings in there. And I remember seeing this, and so when the guy said, you should make a better headset, I thought, And I went and got a couple of those bearings and cleaned them out, right, and made some cups. That was the first headset. To get back to that part of the question that talks about, how could somebody get started in this? You either have to have a lot of capital behind you and time, or you just have time and tenaciousness to stick with it long enough, and a perseverance for what your goal is. Mine was quality.
Yeah.
To stay with that in an unyielding way that ultimately builds a brand name. And in the meantime, I scrapped and suffered and had a great time and learned an incredible amount. It certainly wasn't about making lots of money. It was just about being passionate about wanting to make a good product.
Sure. Now that leads on really to the next question from Daniel Quinnell, who asks, how healthy is the bespoke cycle industry, and is the future bright for it?
Well, cycling industry has been going through cycles since it's been around, right? And the bespoke part of that, I've seen it kind of go up and down over the years. When I first got into cycling, all of the bespoke type frames and so on and so forth that were being produced here.
Yeah.
And in Italy.
Right.
So I remember running into this one guy. He became a designer for Specialized years ago. He had arranged for Bob Jackson to come over to Santa Cruz and give some frame building lessons.
Wow.
And this particular guy took those lessons and became a custom frame builder. And that's part of what got the whole custom world going in the States. Mm-hmm. That was in the about mid 70s. So by the early 80s, all these custom builders were starting to pop up. So that's people like Eisentraut and Bruce Gordon and a bunch of the guys on the East Coast. And that's got this whole thing going in the States. In the meantime, everything that was going on over here was starting to kind of go down. And I was surprised in more recent years to find that it had almost died out. I don't want to say completely, but it had died way down here, right? And now we're seeing, every time I come to the show, there's more and more stuff. Yeah. More and more people doing this. It's starting to quiet down in the States a little bit. Yeah. Where the epicenter of that is, or where it's really happening or expanding or whatever, is going to move around. But the overall is going to be probably kind of a consistent percentage of the overall bike world. Yeah.
So Steve H wants to know, is there many gains to be had from changing from a normal bottom bracket to a ceramic one? So in terms of the bearings?
On race day, if you want the least amount of drag in your rolling components, you could actually run those bearings dry.
Yeah.
Or with a slight dry lube or just a drop of really light oil.
Yeah.
And eliminate all that grease drag that you might normally have in a regular bearing. Now the bearings that we've been putting in our hubs and the grease that we've been using is a really low shear grease, so it's pretty good.
Yeah.
It's better than what you typically get in a shop. But at the same time, there's still a bunch of that in there, and as the faster you go, the more it wants to resist. When you make that thing dry, you definitely get way better performance. The thing that we've also found, at least in our bearing technology, by going to a ceramic ball, you actually wind up with a bearing that our bearings become even more durable with those balls.
Right.
Where you have people using our components in bad weather conditions and dirty weather conditions, all that kind of stuff, the ceramic bearings are probably going to be superior.
What makes a stiff wheel? Stiff rims or stiff hubs?
Well, it's all of it.
Yeah.
Obviously. I think largely, each component that goes into the wheel build is going to either contribute or not contribute to the overall stiffness of the wheel. And then how do you actually lace that thing together? How tight? How much do you tension the spokes?
Yeah.
My hoop is pretty damn important because most of the time I'm sitting on the hoop unsupported.
Yeah.
So the rest of the hoop has to add to that. How that hoop is then supported from the hub out becomes very critical, because if I don't support the top properly and the two sides properly, that they can do this or that, then that bottom's going to be able to move around a lot or whatever, right? So you can see that the whole thing is pretty critical.
Yeah.
Types of spokes, spoke tension, cross patterns. So it depends on what you're looking for out of that stuff, right? If you're looking for durability of the wheel in, say, a downhill application or something like that, well, chances are you want something that's a little more symmetrical. Yeah. But if you're looking for really like sprint performance, you probably want that dish in the back to a certain degree.
Yeah.
I mean, you're fighting between how well it hooks up and delivers power to the ground to how well it stays, laterally stable, right?
Sure.
It's kind of a cross of those two things, right?
Got a question from Alan Zarchinsky. Now, I'm presuming he's got one of your old hubs. He says, is there a way to change his old mountain bike disc rear hub to fit modern road bike? Now, he doesn't give any standards or anything like that, but I'm guessing that there's probably some axles and kits.
We do some axle kits for conversions, and depending on the road bike, you could have a bike built with a slightly wider spacing, because the old mountain stuff was 135, and your typical road's 130. It's not very far. A lot of the cross stuff that I've seen go by in more recent years has been built to 135. Mm-hmm. We certainly, you could certainly do that. Yeah. Whether you get the big issue with using a fixed mount disc rotor type of hub, which is what we make now, it then becomes, where does it put the disc?
Sure.
You can get, there's an axle arrangement that we probably sell where you can get it into just a standard road bike at a 130 spacing. But whether or not you're going to get that disc at 15 millimeters away from the dropout face, that's another story.
Yeah.
Now, if you have a caliper or a way of mounting that caliper that can make up for that difference, you're off and running.
Fill your boots. I've got one then. Ben Vinson. How did 72 points of engagement come to be a standard for your rear hub? Now, it's not a standard across, is it?
The idea of making this the type of ratchet that we have now, that idea goes back to high school. And we were still using screw-on freewheels at that point, right? So it was going to be in that kind of a thing. The idea of using a helix with it came later. That was in the very early 90s when it dawned on me that I could make that thing move on a helix and it would have a clamping effect. I was trying to, at that point, simulate the rapid engagement that you would get from a roller clutch.
Yeah.
Because that was theoretically practically speaking, it wasn't zero, but it was a very small amount of movement, right? So the initial prototypes were all made at 90 teeth.
Wow.
90 teeth is about 4 degrees of movement between engagements.
Yeah.
When you calculate through your typical low gear on a mountain bike, back to your crank, back to your pedal, you get about somewhere between 3.5 to 4 degrees of actual motion before you're actually delivering power to the ground, right?
Yeah.
So 4 degrees was my target at the time.
Yeah.
That was 90 teeth. When we went to 72, I think it moved up to about 12 millimeters. But it was still, compared to the typical 18 or 20 engagement systems that were out there, I think Shimano at the time was 16. That was like 2 or 3 inches.
Right.
When you tried to dice your way up some little climb or something like that, and you had to reset your pedals to get through some tight spot, there's a huge difference in how that feels. So having something that was really quick was really important.
Yeah. Snappy engagement.
That's snappy engagement.
Now, right, so I'm going to stay with the rear hub, and this is something I get asked so many times regarding free hubs. Now, they want to know, is there any relationship between sound and the efficiency of the hubs? So is a silent hub more efficient than a loud one? Because obviously your hubs, they've got that buzz sound, the angry bee, some people call it.
And that's just a funny thing. I mean, having started that project with a roller clutch, those were perfectly silent.
Yeah.
And my goal was to have the ratchet be silent also. So we had started on a grease project to have an acoustical quality to it that would keep the hub super quiet.
Right.
We got about halfway through that grease project. We got all the lubricity part of it done and so on and so forth, and we were about to move to the acoustical side of that. And we just started getting this feedback that everybody loved that sound. Oh, yeah, because I tell people, our next step is to make the things silent.
Yeah.
Whoa, you're not going to make them silent, are you? No, we like that noise. I mean, are you kidding me?
Yeah.
Come on, really? The angry bee, right?
Yeah.
If you look at the roller clutch, someone might say, well, here's something that's perfectly silent, right? Roller clutches use kind of a wedging system for wedging the roller into a tight space, thus jamming it up, creating this friction between the roller clutch itself and the shaft that's spinning in it.
Yeah.
In order for it to be engageable in the first place, those rollers always have to drag on the shaft that they're trying to lock up.
Yeah.
So, even though it may be perfectly silent, there's some kind of drag involved in ultimately getting it to engage.
Yeah.
The new Shimano hub that's supposed to be coming out that's silent is going to have a similar issue to that. There's going to be some kind of drag involved that's going to be there to have the mechanism cause the engagement to happen once you start pedaling.
Yeah.
So now the argument becomes, is that drag more or less than the amount of energy that's going into that clacking noise?
John Leach, he's curious. Have you ever experimented with other materials in your product range? Magnesium, titanium, that kind of thing?
Of course.
Yeah.
And, sometimes you get a bright idea. It's like, wouldn't it be cool to make this out of this or that? And you get down that road and it's like, it's strong enough. It's kind of hard to machine, but we can still do that. And you get down, sometimes you just don't see a problem that really is going to come along with that. Yeah. When we first produced the R45s, they came with titanium drive rings.
Yeah.
So we thought, we can make the thing a little lighter. We can machine titanium. It's not that big of a deal. I mean, it does take a little longer, and the material is more expensive by a long shot. But we thought that would be kind of cool, and roadies tend to like that high-techy stuff and all that stuff.
Stuart Dreyer, he says, if you were king of the world, well, he's the king of the bike industry, isn't he? Chris King, after all. What bottom bracket standard would prevail?
Well,
it's a tough one, this.
I'd say T47.
Of course.
And I think we came up with something that's absolutely workable, right? The 1 millimeter pitch, some people say, oh, it's too fine. Yeah, maybe it should have been a little coarser, but we didn't have the ability to go deeper on the thread because of the tubes available and stuff. And I wanted something that, quite honestly, you could run the taps into a press fit bottom bracket and turn it into a threaded bottom bracket.
Yeah.
So we wound up getting all of that in T47.
Neat solution, really.
It's genius.
Yeah.
And to think, I mean, we've been using threaded bottom brackets for how long now?
Oh, donkey's years. I don't know.
Decades.
I still
and
use
decades.
them on some of my bikes, so, you know.
In terms of what's out there right now, I think T47's kind of the answer.
Right.
And I'm not trying to sell bottom brackets, but I
you
have
know,
one on my bike.
Yeah. Well, you've designed it, so why not talk about it?
It wasn't. It was a group effort to do that. So
a massive thanks to Chris for his time here. Make sure you give this video a big thumbs up, like it, share it with all your friends, and also remember to check out more of our great content. So click down here for the latest GCN Tech show.